Hi. For the 6th day of our Intro to Proofs unit, we're going to take a look at proofs that involve parallel lines. So we're going to start off by doing proofs where we're told that the lines are parallel and asked to prove something based on the lines being parallel, and then we're going to look at how to do it in reverse, where you're given information and asked to show that the lines are parallel. So the first thing that we're going to do is just take a look at some of our properties. Now, when we did the parallel line investigation, I actually had you look at these properties. So really, this should be something that is pretty simple. Corresponding angles. If two lines are cut by a transversal, then each pair of corresponding angles are equal or congruent. The next one, alternate interior angles. If two parallel lines are cut by a transversal, then the alternate interior angles are equal or congruent. Same thing with consecutive interior angles. Actually, we usually will see them called co-interior. If two parallel lines are cut by a transversal, then the consecutive or co-interior angles are actually supplementary, which means that they add up to 180. If you want to put that in your packet, you can do that just as a little reminder. Alternate exterior angles. If two parallel lines are cut by a transversal, then the alternate exterior angles are equal or congruent. And the last one is something that is new. We did not look at this in the investigation. This one says, if a transversal is perpendicular to one of two parallel lines, then it's going to be perpendicular to the other. Okay. Now, those properties actually should go in your packet on the properties, postulates and theorems page. If some of them are not listed there, just add them at the bottom. I think that I only put 3 of them for some weird reason when I printed out the packet. So if some of those are not on there, then just add them at the bottom. All of them will be important. The other thing is that since this is the last lesson, at this point you should have all of your theorems and postulates, and you should also have all of your definitions at this point. If there's stuff that's missing, either go back through the videos and see if you can find it, or if you know what they are, come up with your own definition, or see if you can find them somewhere else, either from a friend or somewhere online where you can get a definition, something like that. Okay, let's actually get into doing some proofs. With parallel line proofs, we're going to start off being given some information about the lines being parallel, and then we're going to have to prove something. In this case, we're going to have to prove that angle 2 and angle 7 are equal and 3 and 6 are equal. Well, if you take a look at the picture, again, it's usually a good idea to come up with a plan before you actually write the proof. So, in the picture, if I look at the angles 2 and 7, and then 3 and 6, both of those pairs are alternate interior angles. And I know that if lines are parallel, then the alternate interior angles are equal. So, to write this proof up, the first thing that I'm going to do is put in my givens. A is parallel to B, and P is the transversal of A and B. And then really all I have to do is say that angle 2 is equal to angle 7, because if lines are parallel, then alternate interior angles are equal. And because angle 3 and angle 6 are also alternate interior angles, I can put that in the same step because it has the same reason. So that was a pretty simple proof. The next one is very, very similar. This time we're told that L is parallel to M, and we want to prove that angle 1 and 8 are equal, and angle 2 and 7 are equal. Well, 1 and 8 are alternate exterior angles, and 2 and 7 are alternate exterior angles. So again, this is a really simple proof. We start off with the given, and then if lines are parallel, then we know that those alternate exterior angles are equal. So our second step is that 1 is equal to 8, 2 is equal to 7, and our reason is that if lines are parallel, which was our given, we know lines are parallel, then the alternate exterior angles are equal. Okay, next one. With the third one, this time we're told that P and Q are parallel and T is perpendicular to P. Well, we just looked at that perpendicular perpendicular transversal theorem, which says that if the transversal is perpendicular to one of the two parallel lines, then it's perpendicular to the other. So if T, our transversal, is perpendicular to P, then it has to be perpendicular to Q. So again, this is a pretty simple proof. Start off with our givens, and then the second step would be that T is perpendicular to Q because of that perpendicular transversal property. Alright, now the next one that we have on here is just a little bit trickier. With this one, we have actually three parallel lines. L is parallel to M, and M is parallel to N. So those three lines are all parallel. We want to prove that angle 1 way up here is equal to angle 12 way down here. Now, for this one, there's a whole bunch of different ways that you can do this proof. I would say at least 10 different ways that you can go about doing this proof. What I'm going to do is talk about how all the angles are related. So I'm going to start with my givens. L is parallel to M and M is parallel to N. And then I'm going to take a look at angle 1 and 5. I know that 1 and 5 are equal because they're corresponding angles. I also know that 5 and 9 are equal because they're corresponding angles. And then I know that 9 and 12 are equal because they're vertical angles, which takes me from angle 1 all the way down to angle 12. So using the transitive property or substitution, I can say that angle 1 and angle 12 are equal. Now, the next thing that I just want to make sure that you see is that the converse of those properties are also true. So, converse again is where you take the hypothesis and the conclusion, the if part and the then part, and you just switch them. So, we can also say that if alternate interior angles are equal, then the lines are parallel. We can also say that if alternate exterior angles are equal, then the lines are parallel. If corresponding angles are equal, then the lines are parallel, and if co-interior or consecutive interior angles are supplementary, then the lines are parallel. So if you can show that you have alternate interior angles that are equal, that proves that the lines are parallel. And again, also if two lines are perpendicular to the same line, then the lines are parallel. Alright, so let's take a look at this proof. With this one, what we have are angle 1 is equal to angle 2, and angle 2 is equal to angle 3, and we want to prove that AB is parallel to DC. So if I'm looking at AB and DC, and I look at AC as my transversal, if I can show that 2 and 3 are equal, then I can say that the lines are parallel because 2 and 3 are alternate interior angles. So my proof, angle 1 is equal to angle 2, angle 1 is equal to angle 3, 2 is equal to 3 because of transitive or substitution, and that shows that AB is parallel to DC because if alternate interior angles are equal, then the lines are parallel.